Hi everyone, and welcome back again to the discussion about graphing trigonometric functions, sine and cosine. So last time we actually discussed like how to graph these sine functions, right? This one, this one, and this one, right? Now we're going to do more of these, okay? Because let's just say let's include some complicated sine functions, just like this and this one, right? We're going to graph these sine functions in this video. So without further ado, let's now proceed, all right? So what's the first step again? The first step here is that you need to know your C and D. Remember, your C is the number or constant term inside the sine function, while the D is a constant term outside. Now take a look. You see, we have the d here. It's the number outside the sine function. And we have the c, which is the number inside the sine function. So this is your c and this is your d. So what does it mean? Okay. Now the fact that we have c and d, it means that when your c exists, okay, what we're going to do here is that, wait, there we go. When your c exists, okay, that means that there exists wait, there exists horizontal movement. So that means you're going to move horizontally, basically. Now, the question here is it going to the right or to the left? Okay, is it going to the right or to the left? Since we have negative pi all over 2, that means that you're going to go pi all over 2 units to the right. Right, to the right. Remember, okay, in the first part of the discussion of sine and cosine, which I do believe we talk about the introduction of sine function. Remember, let's go back a bit. All right. Where was it? C. Okay. If you increase the value of C, then the graph will move to the left. All right. Meaning if your C value is positive, it will go to the left. But if it's negative, it will go to the right. So in this case, if you're going to take a look closely, this is not a positive value. It's actually negative. So it implies that you're going to the right direction, not to the left direction. All right? So that's one. Now, next, we have the D. Okay, your D exists. All right? So what does it mean? That means there exists a vertical movement. So let me just copy this one. And let me replace H as V. So there exists a vertical movement. Okay, so similarly, similar question on the C, at what direction it goes? Is it going upward or downward? Because we're talking about vertical movement here. So since we have a negative uh, number here, which is -1, that means we're going to go 1 unit, hold on, 1 unit downward, okay? Because it's negative, right? Because it's negative, right? If it's positive, of course it will go up, right? But since the fact that it's negative, so it means it's gonna go down, right? 1 unit to be particular. Okay, so you now know the C and D, okay? So bottom line, you're going to move the graph pi all over 2 units to the right and 1 unit downward. So that's one, right? Number two, what is your amplitude in period? Okay, so your amplitude is basically the positive coefficient of your sine function. Here, you have a coefficient of -4, right? But remember, again, as I said uh, right now, that in terms of getting the amplitude, it should be positive coefficient, positive. So therefore, It's not negative 4, but rather 4 units. Okay, it's 4 units. All right. Now, how about getting the period? Now, in terms of getting the period, again, it's 2 pi all over b, right? If you remember. So according here, your b is the coefficient of your x, which is inside the sine function. Now, if you're going to take a look, the coefficient of your x here is 1. So therefore, you have 2 pi all over 1. By the way, if you would notice, most of my examples, especially last time, the coefficient is always 1. Of x, I mean, the coefficient of x is always 1. But guys, in reality, not all coefficients of x is 1. Sometimes it could be negative 1 or, what could say, it could be, how should I say this? It could be 2 or any number, all right? So don't, just because I have examples where your b is always 1, it doesn't necessarily mean that your b should be 1. It could be any number, all right? So here, your period is 2 pi. Now 3, we're going to find your key points. Okay. Now, what's the first step? First step, of course, you're going to focus on the first key point, right? So your first key point, you're going to find first your x value. Or what's your x value of your first key point? So here, remember, what you're going to do is you're going to equate what's inside of your sine function to 0 and find for your x. So inside of your sine function, you have what? X minus pi all over 2, right? So here, what we're going to do is that we're going to equate, wait, hold on. Yeah, we're going to equate this one to 0. X minus pi all over 2 is equal to 0. Then you solve for x. So just transpose negative pi all over 2 to the right. You will have exactly pi all over 2. And that is the value of x value of your first key point. That's it. All right. Just like what we did in the last example. Just equate it to 0 and find for your x value. That's it. Okay, now we're going to substitute it to your given functions. So, oh wait, by the way, I forgot to mention, uh, right? We have negative 4, right? I'm sorry, I forgot to mention something. Right? We have negative 4, right? So, yeah, when you get the amplitude, it should be positive. Regardless of the sign, it should be always positive. But you know what it means, right? If it's a negative, it means that the graph will flip vertically. Okay, wait. Sorry. I forgot to include it here. I forgot, all right? Okay, since we have negative 4, okay, since we have negative 4, wait, that's wrong. Since we have negative 4, the graph will flip, wait, will flip vertically. That's it. The graph will flip vertically. All right, because we have negative sign. If it's negative sign, yeah, what happens is you're going to have a graph in, I think you already know, it will flip vertically. Right. Sorry if I keep saying it or not. Anyway, let's continue. Okay, we're going to substitute it here. So negative 4 times sine of your x, which is pi all over 2, minus pi all over 2, minus 1. Am I right? That's it. Okay. So here, substituting it here, uh, pi all over 2 minus pi all over 2 will give you 0. And of course, sine 0 is 0, so 0 times negative 4 is 0. So what's left is negative 1. So your first key point would be pi all over 2 and negative 1. That's your first key point. Now let's proceed to the second key point. Remember, in getting the x value of your second, third, fourth, and fifth key point, what to do? First, you copy the recent x value you found, so pi all over 2, then plus the period divided by 4. Okay? So here, your period is still the same actually. It's 2 pi all over 4. So this is just basically pi all over 2. So therefore, you're going to add pi all over 2 by pi all over 2. So the result here is you'll get pi, it's your x value. Now substituting it to your y will give you negative 4 times sine of pi minus pi all over 2 minus 1. All right? So pi minus pi all over 2, this would give you pi all over 2. Like 2 times pi. Uh, 2 pi minus pi 1, which is pi. So this is basically pi all over 2 if you're going to combine them. So negative 4 times pi all over 2, that's basically 1. So negative 4, then minus 1, negative 5. All right. So your second key point is pi negative 5. That's it. Then I have no space here, so I'm gonna erase the writings here. Hold on. Okay, so we have the first key point, the second key point. Now let's find the third key point and the rest. All right. So let's go finding the third key point. So the third key point, what's that again? Yeah, the third key point is, yeah, if you're going to find the x value, you're going to add the recent x value found, which is pi, by pi all over 2. All right, so this would be 3 pi all over 2, right? Times pi, 2 pi plus pi 3. 3 pi all over 2, right? 3 pi. That's weird, but okay. So next, yeah, okay, we're going to substitute it to your y. So we have negative 4 times sine of 3 pi all over 2 minus pi all over 2 minus 1. So 3 pi all over 2 minus pi all over 2 will give you, I think that it's still pi though. Like 3 all over 2 minus 1 half. That's 2 all over 2. That's 1. Yeah, it's pi. So negative 4 times sine pi, which is 0. So 0, then minus 1, negative 1. So you have 3 pi all over 2, negative 1. So that's your third key point, all right? Let me put it here. Your third key point is 3 pi all over 2, negative 1. Now for your fourth key point, okay, we'll just do the same steps. Okay, so your x would be the recent x value you found, so 3 pi all over 2 plus pi all over 2. So here, this would be 3 plus 1, 4. So that would be 2 pi. That's your x. Now, substituting it to your given sine function, negative 4 sine of 2 pi minus pi all over 2 minus 1. Okay, 2 pi minus pi all over 2, I do believe that's 3 pi all over 2. 2 times 2 pi, that's 4. Yeah, 4 pi and minus 1, 3 pi. Yeah, so it's 3 pi all over 2. So negative 4 times 3 pi all over 2, that will give you negative 1. So that would be positive 5. No, positive 4, sorry. Negative 4 times negative 1 will give you 4. Minus 1 will give you 3. All right, that's it. So therefore, your fourth key point would be 2 pi and 3. Okay, so let's bring it down here. Then last but not the least, the fifth key point. Okay, the fifth key point. So you're going to find your x by, again, adding the recent x value you found, which is 2 pi, added with pi all over 2. So 2 pi plus 2 pi times 2, 4 pi. So 4 pi plus pi is 5 pi all over 2. Now find your y value. You have negative 4 times sine of 5 pi all over 2 minus pi all over 2 minus 1. So this one, 5 pi all over 2 minus pi all over 2, that's the same as 5 minus 1 all over 2. So that would be 4 pi. So that would mean you will get negative 4 times sine of 2 pi. Right, this is 2 pi basically. So negative 4 times sine of 2 pi will give you 0, then minus 1, negative 1. So therefore, you get 5 pi all over 2, negative 1. Okay, that's it. So that's your fifth key point. Okay. So we're done finding the fifth key points. Now the fourth step is you're going to trace them. Okay, so let me just draw the line here. Then we're going to put a vertical line. Okay, so I'm going to put my integers, and the common difference would be basing from this. So that means I'm going to add pi all over 2 continuously and consecutively. So with that, let me just pass forward this, all right? Give me a moment. Okay, there we go. Then what we're going to do is we're going to put the integers for y-axis since we have like negative 1, 3. So I think let's do it until I believe 6. I guess so. So let's take a look. All right, this is 1, 2, 3, 4, 5. Let me add another one. All right, that's 6. All right, we will do the same thing here below. You have negative 1, negative 2, negative 3, negative 4, and put it down here. Negative 4, negative 5, and lastly, negative 6. Okay, there we go. Let's plot them. Start first with the first key point. Your first key point here is pi all over 2, negative 1. So pi all over 2, negative 1, so it's here. All right, let me just fix it here. So it's here. All right, let me just draw here. All right, at that point. Then next, pi, then negative 5. So pi, negative 5, that would mean it's here. Next, 3 pi all over 2, negative 1. So 3 pi all over 2 is here, negative 1 is here. So I assume it's here. There you go. Then next, your fourth key point, 2 pi 3. So 2 pi here, 3 is here. So it's here. All right. Then lastly, 5 pi all over 2, negative 1. So 5 pi all over 2 is here. And negative 1 is here. That's it. There we go. Then we trace them. Okay, we trace them. Now, we will start here, of course. This is the first key point. So we'll start here, 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 and no, wait. It's not that good. Let me fix that. Here, then here, then here, here. That's it. Okay. Now, we already traced them. So what's the next step? We can expand them, which is the last step. All right. So expand them. Okay. Just follow the pattern. And of course, when it comes to following the pattern, all right, just be careful because like, you just moved, your, I mean, wait, let me explain later, like in terms of movement of the graph. But what I'm trying to say here is that, just follow the pattern basically, all right? Uh, especially if you're, yeah, if like what part that you're going to stop going down and at what part you're going to stop going up, all right? The pattern here, if you're going to observe, it's It's basically, wait, let me write it here. It's basically middle, down, then middle, then up, then middle. So that's the pattern we're going to follow. All right. So that means I'm already on the middle part, which is the last part. So the next step is I'm gonna go down. All right. So for the next x value, I'm gonna go down. I'm gonna stop until, of course, at the maximum point, which is here. Okay. I mean minimum point, which is here. So that means I'm gonna stop on, wait, until here, if I'm correct, here. All right, here. No, that's not, right, there we go. No, that's not a line. All right. Then after that, we're gonna go up in the middle again. So that means here. Okay. Then here I can stop here, then put an arrowhead. Okay. I can do that. That's it. Right, that's an arrowhead, by the way. An arrowhead. There we go. Now we can expand it as well, going to the left. So here, just do it in reverse. So right, it's middle, down, middle, up, middle, right? So here, this is basically middle, up, middle, down, middle. That is what we're going to do. So let's proceed. So here, for your next value, you are going to go up. Okay, so that means you're going to go up to 3 here, up to 3 here. That's it. Then for your next x value, you're gonna go down. You're gonna go middle. So here, no wait. So here. Then I'm gonna go down. That's it. Huh? Wait. There you go. Then go middle again. Then go up again. All right. Then going back to the middle again. Then gonna go down. Nope. That's it. Then here you can draw an arrowhead. Yeah, that's it. That is basically the graph of your sine function. Now, if you're going to take a look closely, all right, let me just use a pink color here. If you're going to take a look closely, compare that to the previous examples we graphed, okay? So let's start from here. You see, these examples, like let's start from the very beginning, the graph of sine x, you see the midline is here, right, on the x-axis, okay? The same way to the graph of 2 sine x, the midline is also 2 sine x. And of course, for the next example we solve, which is negative 4 sine x, the midline is also here on the x-axis. All right. So compare that to here, which is this one, 1/2 sine x plus 1, and this one. Where's the middle line? Okay. Because there is a sudden shift or movement, the middle what was one? The middle line or midline may be affected or not. Okay. Last time, take a look. We graph this one, all right? We graph 1/2 sine x plus 1. Because there exists 1 here, that means you're going to move upward 1 unit, okay? 1 unit upward. And now let's take a look. Where is the midline? So here, the midline is basically you're trying to uh, trace these 3 dots here. You're trying to trace these 3 dots here. There you will find the midline. All right. That shows that the graph really moves upward by 1 unit. Likewise, in this case, okay, if you're going to draw the midline here, okay, you're just going to draw it by tracing these three red dot line here. So the result would be like this. Or you know what? Let me just not dotted line. Let me just draw it a straight line. Okay, it would look like this. Wait, no, just draw a straight line. There we go. Okay. I hope you see the pink line here. There you go. See that pink line? That's the midline. Now, why did I focus on the midline? Because the midline will actually tell you if your graph will move upward or downward, right? So that's the thing. If you're going to observe, it seems like it moves downward, right? Downward by 1 unit long. 1 unit downward because you have your d as -1. Another thing, right? We started here, right? This is the first key point, right? That's the first key point, right? So the fact that the first key point is not on the y-axis, it's not here basically. That means that the graph moves high all over 2 units to the right. Okay, so not only there's a sudden movement of the graph from upward or downward, I mean, actually it goes downward, but there also exists a movement that goes to the right. So therefore, if your first key point is not along the y-axis, or basically it's not located on the vertical axis or line, then that means the graph moves horizontally speaking. So in this case, it is actually proven that there exists a movement, which is pi all over 2 units to the right. All right, so that's it. Then what's next? Then we have the amplitude, okay? The amplitude here, we have 4 units, right? So that means the distance between the midline and the maximum point would be 4 units. And the distance between the minimum point and the middle line is 4 units as well. Let's prove it, okay? So here, this is 3, right? This is 3. Here below, you have -1 as your y. Okay, this is -1. So get the distance between -1 and 3 here, okay? So 3 minus -1 is exactly 4. So it is in fact 4 units. Likewise, in this case, on the minimum point, your y is -5, right? And then your here on the middle line, it's at the -1. So -5 minus -1, that would be the same as -5 plus 1, which is -4. It's negative, yes, it is negative, but I know if you're going to disregard the negative sign, like let me erase it. This is +4, right? Still, it shows the distance between between the middle line and the minimum point is the same as the distance between the middle line and the maximum point. So therefore, the amplitude here is in fact 4 units. So in other words, your graph stretches vertically 4 units, okay? It stretches vertically by 4 units. Okay, that's it. Okay, that's how would you um describe your graph here. Okay? Let me just erase the pink line. Right? There we go. All right, that's it. Now let's try the last one. All right, last one. Okay. I think I'm gonna change the last one because you see last one, I kept having X as I kept having B as 1. So let me just change it. Let's make it 3. Okay, 3x. No, wait. Let's make it 3. Because I'm tired. I'm tired of using b as 1. Remember, b is a coefficient of your x. So here, what I'm trying to say is that the coefficient of x here is 1. And to relate that in my previous examples, it's always 1. So let's try something new. Okay, how about 3? All right? Okay, so what are we going to do? Same steps. Number 1, you really, really need to know your c and d. You need to know your c and d. So here, you see, I think there exists the D and C. Okay? Let's start first your C. Your C here is -2. And your D here is 1, right? So what does it mean? Okay, let's start slowly for your C. Okay, let's go slowly for your C. So if there exists C, what does it mean? Okay, so here, since your C is -2, what does it mean? It means that there exists a horizontal movement. Okay, there exists a horizontal movement. Okay, and now that there is a horizontal movement, what does it mean? Is it going to the right or to the left? If it's going to the right or to the left, how long will it take then? Or how far will the movement be? Okay, so I forgot to mention to you guys, right? I get pi all over 2 units, right? Okay, so how did I get pi all over 2 units to the right? How did I know that it will really move pi all over 2 units to the right? If if you're going to take a look closely, um, your x here has a coefficient of 1. And then there is a number here, which is pi all over 2. Okay, so here, if it's negative, that means it will move pi all over 2 units to the right. If it's positive, it would mean pi all over 2 units to the left. Okay? But in this case, however, in this case, you see your b is not 1. Okay, your b is not 1, but rather 3. The coefficient of your x is 3. So here, the way how you will find how far it will move, horizontally speaking, will be different in finding how far will this sine function move when the b here, or the coefficient of your x here, is 1. Okay? So in this case, it's like you're finding the first the x value of your first key point, which is basically equating this one to 0. Then find for your x. There you will know how far it will move. So just transpose 2 to the right, you will get 3x is equal to 2. Then divide both sides by 3, you will get x is equal to 2/3. So therefore, it means that you will move 2/3 2/3 unit to the right. Right, to the right. So yeah, that's basically it. So here, yeah, now you know that that is what you're going to do if you want to know how far it will go. Okay. Next is your D. Your D here is 1. So of course, if there exists D, that means it exists vert there exists vertical movement. Okay, there exists a vertical movement. So in this case, if there exists a vertical movement, how far will it go? Okay, or rather, what direction will it go as well? Not only when we want to know the magnitude, but the direction as well. You know what I mean? So in here, we have 1, right? And it's positive. So therefore, the graph will move 1 unit upward. Okay, so that's it. All right, we found the C and D and how we interpret it. All right, or analyze rather, or interpret, I guess. Anyway, now next is we go to number 2. Let's find the amplitude and your period. Okay. So in this case, you see, your amplitude is easy. It's still 2 units. Okay. Just get the positive coefficient of your sine function. That is your amplitude. Now for your period, remember it's what? 2 pi all over b. Okay. So here, what you're going to do is that you're going to substitute as your b. Remember, your b is the coefficient of your x. So it's 2 pi all over 3 as your period. Okay, that's it. Okay, now just to give you a short information, what does it mean that your period is 2 pi all over 3? It means that in one cycle, the total horizontal distance is 2 pi all over 3. All right, we will see later. Okay? We will see it later. Next, your third step is find the key point. Okay, let's start first with your x. Okay, let's start first with your x. Okay, so for your x, okay, to find your x, what are we going to do? You will equate 3x minus 2 to 0 and find for your x. So 3x minus 2 is equal to 0. So transpose 2 to the right, you will have 2. Then divide both sides by 3, and you have x as 2/3. And that is your first x value. First, x value of your first key point, 2/3. Okay? Now you substitute it to your sine function. So you have 2 times sine of 3 times x 2/3 minus 2, if I'm correct, yeah, 2 plus 1. So here, 3 times 2/3, this will cancel out. You will get 2. 2 minus 2 is 0. So 2 times sine 0 will give you 0. So what's left is 1. So therefore, your first x value would be 2/3 plus 2/3 and 1. Okay, that's the first. Okay, this is the first, by the way. Okay, first. Let's go proceed to the second. So for again, just to have a reminder, for you to get the x value of the second key point until the fifth key point, just remember, add the recently found x by the number you found by dividing the period by 4. Okay? So we have 2/3, right? So add 2/3 plus the period divided by 4. So the period here is you have 2 pi all over 3, right? All over 4. So let me simplify this one. This one is just the same as 2 pi all over 3 times 1/4. Okay, if you're asking me how I got this, it's just like you're what do you call this one? You're simplifying a fraction that has two fractions. Like for example, a all over b all over c all over d. Just copy the numerator, a all over b, then multiply the denominator, but the positions are switched. So you have d all over c. So in this case, you see you have 4 here. That's just the same as 4 all over 1. So therefore, you have 2 pi all over 3 times 1/4. Then you simplify, right? So here we have 2 and 4. Both of them are divisible by 2. So remove, 2 divided by 2 here is 1. So that will be 1 pi. And 4 divided by 2 is 2. Therefore, you have pi all over 6 as a result. So therefore, we're going to add 2/3 by pi all over 6. Okay, you can combine them if you wish to. Okay, if you want to combine these two fractions, I think that would be much better. All right. So here, if you're going to add a fraction where the denominators are not the same, you will do butterfly technique. All right. So to give you an idea, it's just like this. You have 2/3 plus pi all over 6. Okay. So in this case, okay, for you to get the numerator, you just need to do cross multiplication. So you have 2 times 6, 12. Copy the operation between them. So it's plus. Then cross multiply again. 3 times pi. So 3 pi. That's it. Then next, you multiply the denominator for you to get the denominator here. So 3 times 6 is 18. That's it. Okay, that's it. All right. Then we can simplify this one more time because you see 12, 3 pi, and 18 are both divisible by 3. Okay. 12 divided by 3 is 4. 3 pi divided by 3 is pi, and 18 divided by 3 is 6. So you have 4 plus pi all over 6, plus pi all over 6. Okay, so that would be your x. So that is 4 plus pi all over 6. I have a bad feeling that this would give you a very complicated answer. So I suggest prepare a calculator here because there is a chance that it's not easy for us to find the y value. The fact that we have this x, damn, there's a chance that we can plot this one exactly, but by estimate. Okay, later I'm going to explain it. So your y times 2 times sine of, I substitute here your x here, so you will have 3 times 4 plus pi all over 6 minus 2. Okay, here I suggest using calculator, right? I suggest we should use calculator here because what do you call this one? There is again a chance that um yeah, there's a chance that we're going to have a very complicated answer. All right, so let me just open my calculator. Hmm. Oh wait, hold on. Let me just put the charge here. All right, give me a second. All right, I'm back. So when you substitute 4 plus pi all over 6 here in your sine function, here you will actually get an exact answer of 3. Wow, actually. So that means that the key points for a second and the second key point will have the coordinates of 4 plus pi all over 6 and 3. Wow, okay. That's actually amazing. Okay, so let me just erase this one and let's find the other other key points as well. Okay, so there we go. That's it. Okay, then what's next? Okay, let's find the third key point. So x is equal to, add the previously found x by, what's that again? By, oh my God, I actually erased it. Um, Pi all over 6. Okay, I remember. Yeah, pi all over 6. Because remember, when we divide period by 4, it's pi all over 6. Okay, I remember it. Okay, so yeah. So added with pi all over 6. So here, if you're going to add two fractions that have the same denominator, all you need to do is just add all the numerators, then copy the denominator given, which is 6. So here you have 4 plus pi, you have 4 plus 2 pi all over 6. And here we can simplify it because you see both, all the numbers here, or the terms here, are all divisible by 2. So here you have 4 divided by 2 is 2, 2 pi divided by 2 is pi, and 6 divided by 2 is 3. So therefore you have 2 plus pi all over 3. That is your first, what's that again? Your first, no, x value for your third key point. Now, substituting it here to your sine function, you have 2, wait a minute, yeah, 2 times sine of 3 times your x here, which is 2 plus pi all over 3, then minus 2, then plus 1. Okay, so this would give you, okay, 2 plus pi all over 3 will give you exactly 1. All right, this will give you exactly 1. Therefore, your third key point is 2 plus pi all over 3, then 1. Okay, let me just put it here. And that's it. Now, let's do the same thing for the fourth and fifth key point. So for the fourth key point, I add the recently found x, which is 2 plus pi all over 3 by pi all over 6. Okay, so here, if you're going to observe, not the same denominator. So what does it mean? You will do butterfly technique. Okay, so let's get the numerator first by cross multiplication. 6 times 2 plus pi, that would give you 12 plus 6 pi. Then next, copy the operation between them, so that's plus. And then cross multiply. 3 times pi will give you 3 pi. All over the denominator below, 3 times 6, 18. That's it. Okay, then we combine similar terms. So 6 pi plus 3 pi, that would give you 9 pi all over 18. Now, all of the terms here are divisible by 3. So 12 divided by 3 is 4. 9 pi divided by 3 is 3 pi. And 18 divided by 3 is 6. So that means you have a simplified answer of 4 plus 3 pi all over 6. Right? So that is your x. Now we're going to find its y value. So you're going to substitute it to your sine function. 2 times sine of 3 times 4 plus 3 pi all over 6 minus 2 plus 1. Okay, so in this case, this would give you 4 plus 3 pi all over 6. Negative 1, okay? This is negative 1. So therefore, the coordinates of your fourth key point are 4 plus 3 pi all over 6 and negative 1. That's it. So you're going to put it here. Okay, then lastly, we're going to find the fifth key point. All right, so for your fifth key point, let me put it here. Anyway, yeah, fifth key point, x is equal to, okay, so recently we found 4 plus 3 pi by 3 pi all over 6. Then we will add it by pi all over 6. Okay, so both fractions have the same denominator, so just add them. 4 plus, add all the numerators. 4 plus pi plus pi. Oh, no, 3 pi. Forgive me, it's actually 3 pi. Right, 3 pi plus pi, then copy the denominator. So 4 plus 3 pi plus pi, this one, and these two are similar terms, so you can add them together. So you will get 4 plus 4 pi all over 6. So all of them, okay, if we're going to simplify it, are divisible by 2. So 4 divided by 2 is 2. 4 pi divided by 2 is 2 pi, and 6 divided by 2 is 3. So therefore, your simplified answer is 2 plus 2 pi all over 3. Okay. I'm going to leave it that way. I think that's much better. Then now we're going to substitute that x to your sine function, which is 2 times sine of, 3 times 2 plus 2 pi all over 3 minus 2, minus 2, I plus 1. Okay, so by my calculator, the answer would be 1. Okay, your y is exactly 1. So therefore, your fifth key point will have the coordinates of 2 plus 2 pi all over 3 and 1. That's it. So we're gonna bring the fifth key point here, and yeah. Okay, so now what we're going to do is we're going to graph them. We're going to graph because the fourth step is you're going to trace them. But here's the problem. I think it's hard for you to trace them. You see, because let me give you an idea, all right? Let's start first with the second key point. You have 4 plus pi all over 6. If you're going to get the approximate value, this is just basically approximately, let's just say at 4 decimal places, 1.1903. How are you going to plot this one, right? Especially two-thirds. I believe two-thirds, it's 0.6666 and so on and so forth. So in this case, how are we going to graph them? So here, we can't exactly know what would be the positions, or you know what I'm like. We can't exactly know, um like, how can I explain this? It's like, compare that to the previous key points. You can plot them easily, but here we can't. Okay, because it has decimal value. So the best way here is to approximate it or just estimate it. That's fine because overall we are told to graph it manually. So we're not computers who can graph it with extreme accuracy and precision. So what we're going to do is just estimate it. All right. Okay. So let me just draw the graph. Draw the lines first. Okay. So let me draw the lines here. Then let me put first the integers. So give me a sec. All right. So I already put all the integers for your x value, for the x-axis. If you're wondering how I got this, is because of pi all over 6. All right. Just simply continuously and consecutively add pi all over 6. Right. This is your starting point. 0, 0 plus pi all over 6, pi all over 6. Pi all over 6 plus pi all over 6, pi all over 3. Pi all over 3 plus pi all over 6, pi all over 2. Right? So yeah, that's it. Just continuously add them. Okay, now for your y, since we have like 1, -1, 3, let's do 4. All right, let's do until 4. All right, so that means I have 1, 1, 2, okay, 1, 2, 3, 4. Here you have -1, -2, -3, and -4. That's it. All right. So now we will now plot them, which is hard. But again, estimate. When you can't plot it out, just estimate. It's okay. We're not computers. All right. So 2/3, that's 2/3 here is another way of saying 0.67. So 0.67, where is it located? Okay, on the x-axis. Okay, so first and foremost, where is pi all over 6? Pi all over 6, you see, it's here, right? Pi all over 6 is approximately, approximately 0.52, all right? Then pi all over 3, okay, pi all over 3 is approximately 1.05. So what I'm trying to say is that 2/3 or 0.67 is located somewhere between the two. All right. Now, which x integer here is closer to 0.67? Is it pi all over 6 or pi all over 3? It's pi all over 6. It's closer to 0.52. So in this case, what we're going to do is just imagine that we're just gonna draw a what goes one? Draw 0.6 here, okay? I mean the x value, which is 0.67, it's here. Okay, imagine 0.67 is here. Okay, it's here. Then you plot it. Plot the y value. So your y value is 1. So it's here. Okay. Okay, so it's here. That's it. Again, guys, it we do not need to be very, very accurate, okay? Because we're not computers, okay? We can just estimate it, all right? Like next, your second key point here, we have 4 plus pi all over 6. So by calculator, 4 plus pi all over 6 is again approximately 1.19, okay? And again, what's pi all over 3? Pi all over 3, I do believe I forgot. Wait, what's pi all over 3 again? Sorry. Pi all over 3 is 1.05. Okay. Then I believe that pi all over 2 is greater than that. Okay, because pi all over 2 is 1.57. Right, let me put this pi all over 3 here. So meaning, guys, 1.19 is between pi all over 3 and pi all over 2. But since 1.19 is closer to pi all over 3, so just imagine your x value is closer to pi all over 3. So it's here. Then we plot its y value, so it's 3, so it's here. So we have this one. That's it. Okay, that's it. All right. Next, for your third key point, we have 2 plus pi all over 3. So 2 plus, wait, let me just erase, wait, no. Okay, let me erase this one. Okay, so anyway, um, 2 plus pi all over 3 is approximately 1.71. All right, which is actually closer to pi all over 2. So I think, guys, you get the idea what I'm trying to do here. Whatever x value it's close to, then I think it's easy for you to plot and to assume as safely as possible where would that x value be. So since 1.71 is close to pi all over 2, which is 5.7, 1.57. So I'm just gonna plot it here. The x value, 1.75, is just here. That's it. Then plot its y, so it's here. It's 1. So that means I have this one as result. There we go. Okay. Now we will do the same thing as well to the other key point. So we're on the fourth key point now. So here we have 4 plus 3 pi all over 6. So this is 2.24. Okay. This is 2.24. 2.24. Okay. And then I think it's actually closer to 2 pi all over 3. Let's take a look. 2 pi all over 3. Yes, it's closer to 2 pi all over 3 because you see 2 pi all over 3 is approximately 2.09. So that means I can estimate that 2.24 is just near here. Right? This is 2.24. Now, plot its y value. So we have -1. -1 is located here. So let's just say let's just say I'm gonna draw it here. Here. Right, this one. I'm gonna draw it here. That's it. And lastly, oh wait, lastly, for your last key point, is 2 plus 2 pi. 2 plus 2 pi all over 3. So this one is 2.76. So this one, once again, it's closer to 5 pi all over 6. Let me take a look. 5 pi all over 6. Yes, 5 pi all over 6 is approximately 2.62. So in here, we can just assume that what cross one? What's that again? 2.76 is just here. Okay, in here. It's just here. Then plot its y value, which is 1. So that means it's here. It's here. So therefore, it would be here. That's it. And yeah, that's it. Okay, we already plot them. Remember, this is just estimate, okay? This is just estimate. This is not a exact plotting like what we did previously. This is just an estimation. But at least you get the idea how to graph them if ever you can't graph it exactly. Now, what we're going to do is we're going to trace them, okay? So, wait, what color did I use? Oh, it's blue. Okay, so by tracing them, okay, so start from here. This is your first key point. So from here, going up, going down, down, then up. That's it. Then let's expand it. Okay. So here you see the pattern. The pattern here is that It's middle, up, middle, down, and middle. That would be our pattern. So since we're on the last part, so our next step would be going up. Okay, so let's just again estimate. Okay, so here what I will be doing is I'm gonna draw here. All right, that's up, then middle here. I'm gonna stop right here. Right, let me just put an arrowhead. Now let's expand going to the left. So the pattern is reverse. You start here, we go down, then middle, then up, then middle. Okay, so middle, down, middle, up, middle. Okay, so in this case, we're going to go down. Okay, so down here, then middle here, then up here, then middle. That's it. Then let's continue the pattern again. So we will, oh wait, no. Wait, hold on. Okay, if I'm gonna go down, I would follow the height of your minimum point. Okay, so down, there we go. That's it. Then middle, that's it. Then up, there we go. Then middle, I do believe it's here. All right, that's it. Now we'll continue the pattern again. So we go down until here, right? Here. That's it. We go down. Wait, no. We go down just here. Then we go middle, so here. Then we go up. And I think I'm gonna stop right here. All right, there we go. And yeah, that's it. That's the graph. Okay. Now, how are we going to interpret this one? So let's start first with the middle line. Of course, the middle line is just basically just trace these three points here. So you have this one. Okay, it's this one. Okay. Now, if you're going to observe that there is actually a movement of a graph, vertically speaking, because again, initially it should be here, right? But then the midline is at exactly 1. That means the graph moves upward by 1 unit. So that's 1. 2, if you're going to observe that the key point, first key point is here. So again, initially it should be on the y-axis. However, it's here. So meaning there exists a movement, horizontally speaking. So it moves at what magnitude? It's 2/3 or 0.67 going to the right, right? Then what's next? The amplitude here, okay, it's still 2. The amplitude here is 2. Where was it? Yeah, it's 2. That means that wait, let me draw again the midline. That means that the distance between the maximum and the midline is 2 units. So what, right, we have 3 here as your maximum, and then the midline is at 1. So 3 minus 1 is 2. So it's in fact 2. Likewise, in this case, okay, you have 1, -1 here, right, as your minimum point. And here we have 1 as well, okay, on the midline. So here we have -1 minus 1, that will give you -2. But disregarding the sign, the distance between the two, it's 2, disregarding the sign. So yeah, positive, negative. Still, it doesn't change the fact that the value is 2. So that is basically your amplitude. So it means that the graph stretches 2 units vertically. And yeah, this is the graph of, what do you call this one? Graph of 2 sine of 3x minus 2 plus 1. Right? That's it. So that is all, guys. That is how you basically graph a sine. So next video is we're going to talk about cosine. I think in cosine is almost the same as sine, right? But there's only, I believe, few differences. I hope you have learned something in this video. All right. So see you guys soon.